Hey, what's up guys? Today we're going to be converting quadratic functions from standard form to vertex form. And then from that form, we're going to be able to determine what the vertex actually is. Now, for this video, we're just going to be worried about functions where the leading coefficient is either 1 or -1. And then I'll make a different video for coefficients that are greater than 1 or less than -1. All right, here it is, guys. Okay, so just remember that quadratic functions, when graphed, take the shapes of parabolas. And parabolas can either open upwards like this, or they can open downwards like this. And the vertex of a parabola is either the minimum or the lowest point of a parabola, or it can also be the maximum or the highest point of a parabola. So it depends on which way the parabola is opening, but the vertex is either the bottom or the top of the parabola. All right, so when we see a quadratic that's in standard form here, we can determine what the vertex is by converting this into vertex form. And so this is what vertex form looks like. And your vertex is going to end up being h comma k. So it's going to be the opposite of whatever this value is in your vertex form equation. And then you're just going to take the value of k here. And so it's called vertex form because we can readily see what the vertex is without having to do any math. But getting there is a different story. So it turns out how we get there, it's important to notice that this is a binomial squared, right? And so in order to get a binomial squared, we have to factor a perfect square trinomial. And the skill that we know to obtain a perfect square trinomial is completing the square. Because as you can see, this is not a perfect square trinomial, right? This turns out doesn't even factor at all. But even if it did factor, it doesn't factor into a binomial times itself. And so what we're going to do is we're going to complete the square. So how completing the square works is I just pay attention to my x terms. So I'm just going to ignore this constant term for now. And I'm just going to look at my x terms. I'm going to take this number, the coefficient of x, we call it the b value, and we're going to cut it in half. So this is 8, I'm going to cut it in half, I get 4. And then you're going to square 4. So you're going to multiply 4 by itself and you get positive 16. So what I'm going to do is I'm going to add 16. But since I just added 16 out of nowhere, then I'm just changing the expression for no cost, right? I sort of have to pay the price of just adjusting this expression. So if I just want to add 16, then I also need to subtract 16 at the end. And so in total, I've actually added nothing to this expression because positive 16 minus 16 is 0. So it seems like I haven't really done anything, but you'll see that strategically I have done something. So I have my plus 16, and then my plus 20, and then I'm paying the price, right? I wanted positive 16, so now I have to subtract 16 here. And now the reason we did this is because now this gives me a perfect square trinomial that I can factor. All right, and so this perfect square trinomial factors into the quantity x plus 4 squared, and then I can combine the positive 20 and negative 16 to give me positive 4. All right, and now as you can see, this is matching the vertex form. So in this case, a is just 1. There's nothing out here, at least that we can see, so that's just a positive 1. And now here, remember the formula says negative h. So this is negative 4 really is what the vertex is actually going to be, because if I substitute negative 4 in for h, then the negative 4 gives me the positive 4. And so my vertex is going to be 4, 4. Remember, k is this value here, so that's where this 4 comes from. And again, k is going to be the opposite of this. So since I see a positive 4, oh, my fault. H is going to be negative 4 because it's the opposite of this. All right. So now let's take a look at this example. Now here, the leading coefficient is negative 1. So before I even complete the square here, I'm going to ignore my constant term for a bit here and just look at my x terms. And from these x terms, I want to get rid of that negative sign before I complete the square. So I'm going to factor out negative 1 here. But again, I'm just factoring out the negative 1 from these two terms, not from the negative 24. All right, so I factored out a negative 1, so I basically just flipped the sign of this term and this term and put them in the parentheses, because if I were to use the distributive property, you'd see I'd end up back here. But again, I just factored the negative 1 from these two terms, so this negative 24 was unaffected. All right, and now what I'll do is I'll complete the square, because I want that perfect square trinomial to factor into a binomial squared. And so I'm going to take this number, the negative 10, I'm going to cut it in half. I'm going to cut this negative 10 in half to give me negative 5, and then I'm going to multiply negative 5 by itself. I'm going to square it, so I get a positive 25. All right, now this is where it gets a little tricky, because you might be thinking, all right, well, I just added 25, so that means I have to minus 25 to make up for it. But you have to remember that we're not adding 25, because the distributive property tells us that this is actually a negative 25, right? Because negative 1 times positive 25 is negative 25. And so I've actually subtracted 25 from the expression by doing this. And so since I've actually subtracted 25, I'm going to add 25 to make up for it. All right. And now this this perfect square trinomial factors into a binomial squared. So instead of writing negative 1, I'm just going to write the negative sign. And now I'm going to factor this into x minus 5, the quantity squared. And now I can combine my negative 24 and positive 25 to a plus 1. And now again, we are in vertex form. A in this case is just negative 1. And then h, the x-coordinate of the vertex, is going to be the opposite of what we see here. So I see a negative 5. So I know the x-coordinate of my vertex is going to be positive 5. And then the y-coordinate of my vertex is just whatever we see here. And that's going to be a plus 1, positive 1. Okay. All right, let's go ahead and do one more here. Now this one looks a little bit different because we're missing a term, right? Usually we're used to seeing a trinomial when we see standard form, but we can see some where we have a quadratic binomial as well. And it turns out we actually have less work to do here. So we're still just going to start this the same way. Now, since my leading coefficient is positive 1, this isn't a negative x squared. I don't have to factor out the negative 1. I can keep this as it is. And now I'm just going to go ahead and complete the square. So I'm going to cut the b value in half, So negative 14 divided by 2 is negative 7. And then I'm going to square that. And so I'm going to add 49. And then since I added 49, I'm going to subtract 49 to make up for it. And now this here is my perfect square trinomial that I can factor. And that factors to x minus 7, the quantity squared. And then I just have my minus 49 left out here. And now we're in vertex form. So my vertex is going to be the opposite of this, which is going to be positive 7. And then my k value, the y value of the y coordinate of my vertex is going to be negative 49. All right, and with that said, guys, it's been demonstrated.